Have you ever wondered why we can see various types of colored objects around us? Have you ever wondered why, when you look through a glass, you can see through it? That is, it appears to be transparent. Before I can tell you the answer, you need to understand how we see the objects around us. You see, things only appear to be seen when light has reflected from that object and enters your eye. But sometimes, not all types of light enter your eye. You see, light is made up of various types of massless particles known as photons. Each photon behaves as a wave and has a particular frequency, or you can say a color associated with it. When light strikes the object, some part of it is absorbed, some part of it is transmitted, some part of it is reflected. The part which is reflected, it is the one which enters your eye, and that's why you see various types of colors around you. Now, you may be wondering why, let's say, for example, a leaf appears to be green but not red or yellow. For that, my boys, you need to zoom in on the leaf. Now, as we zoom in, we see this. We see a particle known as electrons revolving around a center, which is known as nucleus and is composed of protons and neutrons. Now, I won't go into much detail about the nucleus since it is not related to how we see various types of colors. What I will do focus on is the electron.
The composition of light and the structure of atoms together have an important role in our perception of things. Why some things are colored, why some things are transparent. Before answering any of these questions, let us take a look at the structure of atoms. The orbits in which the electrons revolve around the nucleus have specified values. The difference between any two energy levels or orbits is called the energy gap. In the case of this hydrogen atom, the electron would require 10.2 eV of energy from a proton to jump to the next energy level. So what exactly happens when an electron gets hit by a photon with just the right energy? If a photon has enough energy to transfer or excite an electron from a lower energy level to a higher one, it gets completely absorbed in that process. But the electron won't sit there for long. It will try to de-excite or jump to a lower level by emitting a photon. This de-excitation process in which the photon is emitted is what gives color to all substances. The resultant color depends on the energy of the photon emitted, since energy is directly related to the wavelength by E equals hc by lambda.
Let us now take an atom of a substance which is not transparent. So in that atom, the electrons and the energy gap will be such that the photons will be able to get absorbed and transfer electrons from a lower energy level to a higher energy level, and the original photon in this process will be lost forever. Now coming to the main question, why is glass transparent? The answer to this question also lies in the atomic structure of glass. In glass, the difference between the ground state or lowest energy level and higher energy level, which we call the energy gap, is very large. So the photon should now have a higher energy to get absorbed and excite the electron. But photons of visible light do not have enough energy to transfer an electron from lower energy level to a higher level. Also, the electrons cannot stay in between the energy levels, since that would violate the rules of quantum mechanics. So, the photons of visible light pass through the glass without getting absorbed. But what if we increase the energy of photons? That is, if photons of ultraviolet light or X-rays pass through glass, then the photons would get absorbed. This is one of the reasons why glasses are used for protection against ultraviolet rays of the sun.
So, what about colored glass? We can consider it to be between a solid object that doesn't transmit light and a completely transparent material, just as a solid material would reflect a particular wavelength which gives it its characteristic color. Here, what happens is that instead of reflecting that specific wavelength, it transmits it further on. Putting it in precise words, it would mean that when a white light containing all visible wavelengths strike it, most of the wavelength will get absorbed and not move further on, and that one wavelength which does the trick will be the color seen. So now what if we were to shine a red light on a green filter? Red? Let's consider again. No light would be transmitted through, as red light doesn't have any wavelength of green in it. With this, we would like to take our leave. We hope you've learned something new. Thank you.